Welcome to a new episode of the ITU Journal webinar series, where you can find insights and forward-looking research on future and evolving technologies. The ITU Journal is an international journal providing complete coverage of all communications and networking paradigms, free of charge for both readers and authors. This publication considers yet-to-be-published papers addressing fundamental and applied research, building bridges between disciplines, connecting theory with application, and stimulating international dialogue. Its interdisciplinary approach reflects ITU's comprehensive field of interest and explores the convergence of ICT with other disciplines. We count on your support to make this webinar an interesting experience. Please submit your questions via the Q&A channel at the bottom of your screen. All questions from the audience will be taken during the Q&A session after the talk. The meeting is being recorded and the recording will be made available on the webinar website. Closed captioning is also available for this event. You can enable this by clicking on the closed caption icon at the bottom of your screen. We hope that you will enjoy the talk and we encourage you to stay connected until the end for the Wisdom Corner. I will now give the floor to our Master of Ceremonies.
Hello, and welcome to the webinar series with academics of the ITU Journal on Future and Evolving Technologies. My name is Alessia Magliarditi from ITU, the International Telecommunication Union, the United Nations Specialized Agency for Information and Communication Technologies. It is my pleasure to open our 11th and final webinar of the season with Professor Navid Nikaein from Eurecom, France. So please submit your question via the Q&A channel, and we will address them to our speaker during the Q&A session. And as just announced by our avatar, after the Q&A session, I will moderate the Wisdom Corner, live lessons. So please stay online. Our speaker agreed to a personal chat. He will share with us some lessons learned over the years that might perhaps be useful for some of you. It is my pleasure now to introduce Professor Ian Akyildiz, Editor-in-Chief of the ITU Journal and founder and president of TRUVA from the United States. So Professor Akyildiz is Ken Byers Chair Professor in Telecommunication Emeritus at the Georgia Institute of Technology. Professor Akyildiz has established many research centers worldwide, including in South Africa, Spain, Saudi Arabia, and Finland. He's Editor-in-Chief Emeritus of Impact Factor journals and highly cited at the top of the most prestigious international rankings, visiting distinguished professor in several universities around the world. His current research interest includes 6G wireless systems, terahertz communication, metaverse, and communication in challenged environments. Professor Akyildiz, the floor is yours for your introduction and to present our speaker. Thank you.
Thank you, Alessia. Distinguished guests, esteemed colleagues, and valued participants, a warm welcome to you all, no matter the time of day or your location across our globally connected world. First of all, I personally wish peace for the world, and hopefully we'll have a nice life, especially for the young generation. A lot of problems are going on around the world, and it's really sad to see. Here in the historic and vibrant city of Istanbul, a crossroads of civilizations and a symbol of unity between continents, we gather with great excitement to mark the culmination of the ITU Journal on Future and Evolving Technologies, in short form ITU JFET webinar series, with the highly anticipated Season 4, Episode 11. As Alessia mentioned, this is our final episode this season. Today, we are privileged to host a leading scholar whose groundbreaking work has significantly advanced the field of wireless communications, Professor Navid Nikaein. Before we proceed, let us acknowledge the visionary mission of ITU Journal. Since its launch in December 2020, This journal has stood as a beacon of open access innovation, bridging academia and industry while democratizing cutting-edge research. Every submission is meticulously peer-reviewed, ensuring that only the most transformative and forward-looking ideas shape the future of technology. Rapid rise of our journal as a premier international publication owes much to an exceptional team, including Susan Hassan, Bilal Jamoussi, Alessia Mallarditi, Erika Campilongo, Mario Otero, and many others whose dedication has been truly remarkable. To the brilliant minds in our audience, we invite you to contribute to your pioneering research and collaborate with us in driving the next wave of technological progress. We are also thrilled to announce that our journal has been officially indexed in the Directory of Open Access Journals, which is a major achievement that expands our global visibility and reaffirms our commitment to open knowledge exchange. Now it is my great honor to introduce today's distinguished speaker, a visionary researcher, esteemed scholar, and respected leader, Professor Navid Nikaein. Navid is a renowned expert in wireless communication systems, in particular in 5G and 6G networks, edge computing, and open source mobile platforms. His influential work has advanced software-defined networking, network function mutualization, and cloud-native mobile networks. Navid earned his PhD in communication systems from Telecom Paris Tech. Formerly it was known as l'Honnêteté. It's in Rue Barreau. I remember because I was there in 1990. And Navid received his PhD in 2003, following his master and bachelor's degrees in electrical engineering from the top university, Sharif University of Technology in Iran. Navid serves as the CEO of Bubble Run, a professor at Eurecom in southern France, which is a premier institution in communication systems research, and a board member of the Open Air Interface Software Alliance. His career spans academia, industry, and open source initiatives, positioning him at the forefront of next-generation mobile technologies. His research focuses, as I mentioned to you before, 5G, 6G, edge computing, and Open RAN, and he has been a key contributor to Open Air Interface, an open source platform for 5G innovation. Navid led major European international projects, including 5G PPP, 5G Public-Private Partnership, Monarch, which was a very famous project, multi-connectivity in 5G Transformer, about network slicing, 5G All-Star, which is a project on integrated satellite and terrestrial networks. It's also a very important subject for 6G, as you may know. Additionally, he has been instrumental in 6G research, exploring AI and machine learning in future networks. He has collaborated with industry giants like Nokia Bell Labs, Intel, and Orange. His extensive publication in top-tier venues such as IEEE Transactional Wireless Communications, ACM SIGCOM, IEEE Infocom conferences, as well as IEEE Communications Magazine. Due to Google Scholar, his H index is 47 and the number of citations, 8.5 thousand citations, reflect his profound impact on the field. Currently, his research focuses on 6G, AI-driven networks and terrestrial communications, Open RAN and disaggregated networks, and cloud-native mobile core networks. Personally, I first met Navid nearly 15 years ago during my visit to Eurecom in Sofia Antipolis. Our discussions were deeply insightful, and I really enjoyed meeting him that time. And over the years, I have followed his work closely, witnessing his trailblazing contributions to cloud-native Open RAN, AI-powered network automation, and the open ecosystem driving 6G innovation. Navid exemplifies how theory and practice converge to accelerate progress in wireless technology. Dear Navid, we are truly honored to have you with us today. Your insights will undoubtedly spark new ideas, challenge innovations and conventions, and inspire the next generation of breakthroughs, especially for the young generation. Ladies and gentlemen, please join me in giving a hearty welcome to Professor Navid Nikaein. Navid, it's yours. Thank you again.
Yes. Thank you, Ian, for this nice and good summary introduction of me. I'm really honored to be here sharing this moment with you and also the attendees in this webinar. So without further ado, I jump into the topic of today, which is, we coin it MXAI, multi-X automation and intelligence. And the whole idea is to explore how intelligent RAN automations with the multi-agentic AI could shape the future of our network, and what are the trends, what are the visions, and what are the tools that could help us to go step forward towards more intelligent and more open networks of the future. So today's webinar, I prepared this presentation into essentially 4 building blocks. One is about trends and the motivation of AI, 5G, 6G, and give a little bit of introduction of where are we standing and what are the trends. The next, I will present the vision of the future, like how AI could potentially transform current network and how it's going to be integrated into the networks of the future, which is more a long-term vision. Then I quickly jump into a walkthrough example, which is try to ground us to what is possible today. So in essence, you see 2 extremes. One extreme is the vision, and the other extreme is a walkthrough example, which shows you what is possible today with the tools and the platforms and the knowledge we have today. Then briefly, I will introduce you MXAI, which is a multi-X automation and intelligent platform developed by BubbleRun, to show you how that could be of help. And then I go through the summary and some references and contact. So let's start with the first part, trend and the motivation. So let's start with 5G, which all of us are familiar with. Essentially, 5G, as it is specified by 3GPP, has 2 fundamental segments. It has a core network segment and the radio access network segment. In the core segment, the work of 3GPP was to provide service-based architecture, making sure that different network functions, they could associate and aggregate together to provide the specific services for the end user. So 3GPP completely evolved the 4G core network into a bunch of new network functions. Each could be scaled differently. Each could be used, let's say, for different type of services that originally has been identified by ITU. So it has the built-in network slicing capability in order to allocate different resources to different services and provide the quality of service for those slices. So this was one of the new innovations in the core network, and the whole architecture is essentially cloud ready. Here in the picture, we see that essentially the whole design is a service centric. It, for instance, could support different family of the services, and some of the network functions in the core network could be shared. For instance, in this example, we see that, for instance, a session management function or access mobility functions, they are shared across 3 services, whereas the UPF, for instance, user plane functions, are dedicated to a specific service. Some of them are placed in the cloud side, and some of them are very close to the RAN at the edge access side. When we look at the RAN, the evolution was a bit different. We had at one level disaggregated architecture. So you see here that the G node B, the monolithic G node B, has been splitted and disaggregated into new entities, CU, DU, and RU. We also know that CU is also splitted into CU-CP, CU-UP. This essentially allows to provide the multi-vendor capability to future radio access network, but also to be able to scale different network function and put them in different location as per service requirement. Another fundamental improvement in 5G was the flexible new radio, so 5G NR, which gives a significant amount of functionalities, configuration that has not been presented in 4G. And that was due to the fact that in 5G, they try to be multi-service, which we see here, multi-service. So the whole idea of this flexibility, for instance, one of the major features is a bandwidth parts, which could provide different type of frame format and services to different applications on the top. And we see that there has been a significant progress from 4G to 5G done by 3GPP. Moving forward, when we look into 6G, when we look at the core network, so core network is evolving towards the true cloud native, unified, and intelligent architecture. So there are a couple of concepts emerging, like a microservicing for auto-scaling the network function, like having the user plane function at the edge or even integrated with the G node B to reduce the latency, improve the efficiency, teleco-grade APIs to expose the core network capabilities, and universal subscriber access. When we look into the RAN has evolved into disaggregated, open, software-driven, and also data-driven intelligent architecture. We see from the different initiatives that we saw in the ecosystem of telecommunication, 3GPP, and more generally 5G, 6G. So one is, for instance, vRAN, which decouples network function from the hardware, software from the hardware. SD-RAN, which enables programmability and introduces the separation of the control plane and the user plane. O-RAN, which provides multi-vendor interoperability and introduce open interfaces and unlock the fact that we could do the programmability that was introduced in the SD-RAN, but in a multi-vendor environment. And AI-RAN comes on the top and introduce AI-ML, Gen AI for data-driven optimization and decision-making. So the focus of this webinar is more on the RAN side. I don't cover the core network in this webinar. So we go a little bit deeper into the RAN. So when we look into the O-RAN revolution, so O-RAN has done significant work in opening up the radio access network. We need to know that the radio access network was quite closed and was mainly driven by the vendors, and the whole idea and philosophy of open, neutral, and standardized interface and hardware software disaggregation has been motivated by operators. So operators were pushing the vendors to open up their system so that they can actually have more visibility, more control over the radio access network. Radio access network being the last mile towards the end user, and optimizing the radio access network, having observability is of essential. And this actually gives birth to the ecosystem of xApp and RApp for network optimization. So O-RAN defined new network functions, for instance, near real-time RAN intelligent controller RIG, and SMO, service management and operation framework, and also non-real-time RIG, which is the difference would be the time scale between the control domain. And we clearly here see that we have a control domain, which is a RIG, RAN intelligent controller, and we have a management domain. So these are all having different time scales. We also see that there are different interfaces introduced, for instance, E2, A1, and also R1. This xApp and RApp gives birth to a new model, which is a network app store. So all of us are familiar with our smartphone app store. But again, here, it could be to have a app store where developers could develop network application and then operators could potentially use them. Obviously, there are quite a lot of security concerns that must be considered, but it gives a new business model and monetization strategy for operators to monetize their network much better than what they are doing today. And another important fact in O-RAN is that the decision-making process, which is essentially happening in the control plane, is decoupled from the network structure. So this is essential because it fosters innovation and multi-vendor ecosystem. So as I said, O-RAN has been pushed by the operator. And we see that, for instance, in United States, the government is also pushing for open interfaces and also open source realization of the radio access network. There is this famous OCODU project that is, let's say, pushed by the government, and Linux Foundation is managing, which shows that O-RAN has certain level of viability in the future. When we move to AI-RAN revolution, so here the problem is a bit different but related. We are looking into making the network more intelligent in terms of network operation and optimizations. Here on the right, you see the picture from AI-RAN Alliance that shows different type of usage of AI with the RAN. So one would be AI for RAN, so you embed AI in the RAN. Another one, AI on RAN, so you essentially develop new AI-based application enabled by the radio access network. It is on the top. It is not built in. And AI RAN is essentially sharing the resources between the AI applications and the RAN. So essentially asset reutilization. So we see a strong interplay and synergy between AI RAN and O-RAN. Essentially, AI RAN needs APIs. We all know that the Gen AI LLMs, they are very much efficient when it comes to the APIs. And these APIs essentially could be O-RAN. And in the same manner that I explained about the network app store for the xApp and RApp, the same ecosystem could be used, for instance, for third party to share the agent, teleco agent, to share the models for network optimization. It also enables the app store model. And again, here we also have the decoupling of the intelligence from the infrastructure. So before we had the decoupling of the decision-making and control plane, here we have a decoupling of the intelligence, which is actually quite important because it creates an ecosystem for the third party to innovate. However, there is a catch here. We see that the phase changes in teleco ecosystem and economy that are all driven by AI. If I roll back the time to the let's say a few decades or 1 decade ago before, we always considered that the RAN being the main revenue stream, and anything else would be the cost, like infrastructure, like any applications that we are running on the top of network. But this figure is a new figure that produced by NVIDIA, whereby they are seeing the RAN as a cost and the Gen AI as a revenue, which essentially means that the whole mindset of RAN being revenue, Gen AI being cost, has been reversed. So now that is where I call the phase changes in teleco ecosystem and economy driven by AI, because now suddenly the RAN is the cost, but not the revenue generator anymore. So you may ask, could this happen? Is it realistic? This is maybe just a vision of NVIDIA, and because they are pushing forward, maybe yes, but my answer would be most probably yes. because this already happened in the mobile phones. Like if you consider the Nokia phones back then, the featured phone, 80% of the CPU has been reserved for the modem, which was the revenue, and 20% was reserved for the application that actually you see some of them here, and they were the cost. Now, in the smartphone, obviously we have M CPUs for modem, which are cost, and N CPU for applications, which are the revenue. And here, M is order of magnitude lower than N. So we have 80% more CPUs for applications than for the modem. So if that happens in the, let's say, in the mobile phones, there is a chance that the same happens on the network infrastructure. So the point being, is AI a solution to solve what is coming towards 6G? So 6G has been identified to have extreme complexity in terms of the network, massive number of cells because of the dense deployment, a lot of frequency. So we talk about the spectrum aggregations, configurations. Today, a simple 5G G-Node B has at least more than 400 configuration parameters, if not more. I would even say 1,000. A lot of heterogeneity in terms of service, in terms of the deployment. You saw the disaggregation. So all of this brings a lot of complexity in the network. Also, the environment is highly dynamic, so it needs real-time adaptability, user mobility, interference, traffic demand. So that calls for agility and real-time adaptations to all this dynamic environment. And also, obviously, data overload that all of us we know, enormous data. So these are not user data. These are the network data. Like, in order to optimize the network, we need to get the data from the network. And these are enormous, like because the sampling rate could be as low as 1 millisecond. So this amount of data becomes quite large. Now, if we look at the current AI landscape, what the community of academia and industry are building, the major, let's say, target and the major vision of today that we are seeing is building autonomous network agents that are empowered by Gen AI. For instance, you have here an example that you have an environment, you are observing the environment, and you have some goals, some tools, and some memory, and then you push some action. So they could be enabled by large language models, large action models, large telecom models, or a small language model. So there are different type of models available: RAG pipeline, tool chaining, reasoning, and planning. And also, we also know that there is at one level AI-RAN Alliance that introducing certain dimensions. And we also have on a tier one vendors, Ericsson, they also introduced EIAP, which stands for Ericsson Intelligent Automation Platform, which is an ecosystem of ORAN compliant with the R1 interface, allowing third party to develop agents and algorithms. Agentic AI is essentially coming as a next step in automating network operations, so life cycle management, including planning, deployment, and the operations. Also for management and control operations. So these are actually different type of operations with different time scales, and more specifically FGAPs. For instance, we would like to detect the fault, do the anomaly detection, and do a root cause analysis and resolve it before the anomaly or error could happen. We want to optimize the configuration during the day and the night, micro configurations to optimize the resources along the line. Accounting, optimizing the performance, and also optimizing the security is all the approach that currently we are seeing in both academia and industry. There are also certain trends that we also, one of the believers ourselves, toward AGI for artificial general intelligence. So future network, we believe, will ultimately be driven by AGI-like capability, which essentially able to understand and explain complex context and requirement, and also process multi-source data. So today's is very complex for a Gen AI to process a multi-source data coming from the RAN, data coming from the core network, data coming from the infrastructure, data coming from the energy consumption. So all in all, these are quite difficult for today's large language model to process. And then the system essentially needs to understand high-level intents and network dynamics to figure out how to synthesize the network. So this keyword, synthesize the network, is important. I will come back to that accordingly to the intent that has been issued. Not to mention that we all agree that everything needs to be trustworthy and explainable and human in the loop, so that we make sure that all the steps that have been occurred are correct and validated. Another dimension that we are also seeing is that instead of having a single agent, we are seeing a society of AI agents, in essence, multi-agent system where they collaborate and they reason together. So this collaborative intelligence is able to continuously learn and share the knowledge and the insight and improve itself as the time goes by. That is why previously I referred to self-synthesized network. And this continuous learning is very important from the network's data, synthesizing the future scenarios and improving the strategy to, let's say, optimize the network or align the network with the actual objectives that are happening, whether they come through the operators, through the users, and essentially other service providers, any stakeholders in essence. Our vision from 6G and also the values they are bringing, and this is a kind of a shared vision that I saw also in with other players, and here I try to consolidate and give a shape to this. One of the main value added of 6G is to provide novel insights, such as, for instance, sensing, positioning, and the time. So this really goes beyond just the communication, very important. Another value is built-in high-performance computing and AI services that are built in 6G. So today, a lot of operators, they are building the AI factory for their 5G, 6G networks. So this is very important. And also reusability of network assets, such as HPC and AI, for new services, which is essentially nothing but a monetization strategy and also balancing the resources. Another dimension is that 6G is more than just a transport pipe. So we are now moving towards more ubiquitous, lean, and opportunistic connectivity. So having terrestrial and non-terrestrial network, having, trying to make sure that every opportunity to save energy is met is also very important, and connectivity across different radio access technology, very important. When it comes to QS, we are also seeing that the legacy QS of 3GPP still is not able to provide deterministic QS, and there are more rooms for optimizations for providing on-demand and deterministic QS for the certain applications, for instance, tactile, network, holographic, and so forth. Dynamic SLA, dynamic service level agreement. Today's service level agreements, they are very much static. Once you said you don't touch it, because it could compromise the network. operators, they are not used to change the SLA often, but this could be a venue. For instance, a typical example of dynamic SLA would be that we are in a concert, we are in a football match, and we want to get a new flow from the other videos of the match, and therefore we need to, for instance, subscribe for premium services, and then these SLAs get updated and we get the different video flows from different cameras in the, let's say, studio or in the concert. The network has to come application-centric, and having self-synthesized intelligence helping network to adapt itself to what comes and the dynamics of the network. So now I kind of covered the trend and the motivations from 5G O-RAN to AI and moving forward to the AGI. Now I want to share with you the vision we have and where we think there is a room for research and development. So we are thinking of a new concept. This term has been previously used for network intelligence, but we give it a new definition: self-synthesized networks, which essentially pertain to give the ability of having the ability for a network to self-generate and self-augment its capabilities, knowledge, and skills, and evolve over time and space. So let's a little bit go through this definition again, because I want to stress a couple of points. So network has been designed up to 5G as, let's say, although there are so many flexibility, as I mentioned in 5G, to be planned and put in place, deployed, and then be used, right? In a quasi-static way. So there has been a bunch of, for instance, research papers, concept like cell zooming to adjust the transmit power to increase the coverage or reduce the coverage during the day and night, which shows a significant, for instance, benefit in terms of, trade-off between the performance, coverage, and energy consumption. Now, AI is coming. There are a lot of venues are opening, a lot of things become possible. And we are seeing that network of future should be capable of self-generating themselves and self-augmenting themselves. They learn, they share the knowledge, and they augment their capabilities. For instance, we all know that, for instance, in a Wi-Fi system, it's very difficult to have 100% coverage, right? The problem of coverage could be nothing but a problem of self-augmenting capability of a network to make sure that the coverage during the day and night is maintained based on the performance requirement and the SLAs that the users sign up to. And that means that the network is evolving over time. So you might ask, what are the enablers for this SSN, self-synthesized network? So we have identified 4 pillars that are enablers as we see today to realize the concept of self-synthesized network. So one of them on the very bottom is the zero-touch automation. So automation is the foundation, assuming that you have a network infrastructure in place, 3GPP, O-RAN, everything, let's say, is in place. Zero-touch automation is essentially very much important, and the fact that the approach is more declarative and intent-driven. On the top, we have collective intelligence. So this is not a single intelligence of a single agent with a single model, but rather is a multi-X collective intelligence. So it's a multi-agent system. Each they have different agents, different models, and they collectively try to cooperate and solve the problem. On the top, we have open ecosystem. So this open ecosystem is the best term we found to describe what we mean, which is essentially a space where the agents, the knowledge and data, everything is shared and negotiated and mediated. And finally, on the top, we have a new human-machine interface, right? This interface is not the interface we are thinking today. For instance, some may say the interface could be chatbot, the interface could be intent, but there are a lot of rooms for agent to agent, human to agent, and human to network, and agent to network interfaces that are open and yet to be explored. Moving forward, so here I want to show you in a more classical way how they are actually linked together to realize this concept of SSN. So at the very top level, human to machine interface. So this essentially, we need a much better way to communicate with the machine. Machine being a generic word that includes obviously the agents too. So today we can think of intent-based. Tomorrow we could think of metaverse, AR, VR to have a interaction and communication with the machine. Open ecosystem where you have a reusable environment, negotiation, collaboration, and mediation are happening to come to a consensus, and then sharing the knowledge insight among different players, stakeholders on the top. Collaborative intelligence on the lower level, which is essentially a multi-agent system. They provide universal understanding and continuous learning of the system, understanding the intent and how to delegate the task to different entities in the network. And finally, zero-touch automation, which is essentially the basis to execute the operation and the control that we would like to do on the network, whether it is a control loop, whether it's a management loop. And this helps us to adapt and self-evolve the network. Going a bit deeper, so here is a representation that shows on the top different interfaces like human to machine interfaces or agent to agent interfaces that they essentially interact with the open ecosystem that enables collaboration, negotiation, and mediation across different parties, and then goes to the automation layer with a standardized teleco API. Could be ORAN, could be something that will be defined later on. And this has two branches, has a branch towards the physical network and towards the digital network, which sometimes we call it digital twin for what if analysis and parallel replica of the network to explore different possibilities and scenarios. And this essentially allows for the network to breathe and evolve over time and adapt itself to what is coming. So now that being explained, I want to now bring all of us to the ground, go through a more realistic example, walkthrough example that is feasible today and with the tools we have, and then essentially compare these two extremes together. So if we start from the very top level, there is a user API, a certain interface. It could be a chatbot, it could be an API, where there is a query and answer happen between user and the system. So here we have a agent that could be based on different models. It could essentially use different existing models based on what is needed. So it's not necessarily binded. And this one is as a very high level of the hierarchy is we call it orchestrator agent. It essentially understands the query, what it requires, and then it delegates to other agents. For instance, this agent, orchestrator agent, say at the beginning, how can I assist you today? Then the human operator, or it could be also another agent, will ask, execute a power management strategy to improve the average power consumptions of the RAN node in tracking area XYZ. This tracking area is a well-known concept in telecommunications, is essentially a scope, is a geographical area over 24 hours, weekday period by 10%. So instruction improved, reduced the power consumptions by 10% with 5% performance degradation on the average throughput. So once this is received by the orchestrator agent, says, sure, give me a moment to figure out what is the best strategy. I'm considering, so now it is considering 3 possibilities. Allocating less resources in the XY region deployment. So this goes to the problem of the resource allocation problem. 2, updating the network blueprint and configuration. So now I go to the radio access network, I tune the configuration file and the network deployment to reduce the energy consumptions, or I deploy an xApp and RApp to go to the control loop optimization and try to optimize the performance, optimize the energy consumptions and reach the goal that we set at the beginning. So then what is going to happen is that the orchestrator agent is going to delegate an agent, a specialized agent, to explore these 3 possibilities, right? So this is where task-specific agents come to the picture, and that top-level agent is just nothing but a orchestrator to identify exactly which task could be managed by which agent. Going forward, orchestrator agent talks to the Kubernetes agent. So this, we go to the infrastructure. So imagine there is an agent for managing the infrastructure resources, and instruct reduce RAN power consumptions in the given tracking area by 10%, evaluate options such as dynamic CPU memory scaling, node hibernation, or pod affinity, anti-affinity rules, placement to reduce the energy, and recommend changes with significant power saving potential. The agent, Kubernetes agent, will come back and say, okay, I recommend implementing dynamic resource scaling and node auto scaling based on the traffic pattern that are coming in the tracking area XYZ. And then additionally, it could deploy, for instance, a scheduling policy to consolidate workload in the fewer node and turn off some of the nodes. So this would be the result coming from the infrastructure. We move forward to the SMO, which is in charge of management and operation. So in this case, the SMO agent will say, I can reduce the channel bandwidth. So instead of, let's say, 100 megahertz, I can bring it to 50 megahertz during the low demand hours, for instance, during the night, maybe reduce the cell coverage to go towards the low power usage. They can, for instance, adjust ARFCN to consolidate active carriers, further enhancing the efficiency. So this would be the solutions coming from the SMO agent. And when moving forward, now we go to the control subsystem with the xApps and RApps. In this case, the app agent will say deploying AI-based RApp for traffic prediction and adaptive cell activation and deactivation can optimize RAN energy used dynamically. Furthermore, a sleep mode orchestrated xApp can further reduce the power consumption. So these are different agents coming with different solutions. So we have now 3 solutions. We have a green solutions coming from the infrastructure. We have a purple solutions coming from the management and operation subsystem. And we have a dark red solution which coming from the control subsystems. Orchestrator agents think and say, okay, the green solution is unlikely to give a better outcome than purple and dark red. So let's discard it. So the green solution is discarded. So now there is a choice to make between the 2 latter solutions, which is the purple and the dark red. So in that case, the orchestrator agent says, okay, let's evaluate this in a digital network, in a digital twin environment. So it essentially ask the DT agent, digital twin agent, to deploy a network in a time-accelerated simulation to see for instance, for 3 days accelerated network simulations to see how much power consumptions could be reduced during this accelerated time, and then come with the results. And this DT comes and say, I see best outcome in the second twin with a 12% power saving and 1.3% quality of service degradation in terms of downlink and uplink throughput. So this third one was the one that related to the xApp. And then moving forward, the orchestrator agent say, I recommend deploying an RAP for traffic prediction and adaptive cell activation, deactivation to optimize RAN energy use dynamically. And this solution led to 12% decrease in power consumption and 1.3 degradation in downlink. And then ask the human operator, should I deploy this? Human operator say, yes, you can proceed. And then orchestrator agent will deploy the solution and say deployment is done. So this is a typical example where it involves an orchestrator agent, specialized agent, and also human operator in the loop, and then coming back with the DT and then applying the best solution into the real network. So with that, I covered a walkthrough example where we could see how this collaborative agent, they can work together, they can communicate and bring the best solution to optimize the network performance. Now I go a bit more towards the tools that could help us in order to validate this concept and bring more clarity as of how much in reality the performance would be optimized and improved. So MXAI stands for Multi-X Automation and Intelligence Platform. It is essentially a LLM-powered agentic platform that accelerates the automation and intelligence in the network. So it comes with the modular and open ecosystem, specifically with the development kits. So for instance, you see here xApp, RAP software development kits. You see also AI agent development kits, and also the core, which provides the end-to-end intelligence. So essentially, it gives us a bunch of tools in a form of the development kit, allowing to innovate and develop logics, develop applications, develop agents, and try to benefit from this collaborative multi-agent environment to optimize the network. One of the features is that it is a standard aligned, so it is following 3GPP and ORAN, so underlying network is 3GPP compliant, and it supports R1 and A1 interfaces. And you see here that vendor A or third-party A could deploy xApp and RAP, and vendor B, for instance, could deploy the AI agent on the top, and then the result would be seen in the data lake, and this allows to have observability of the whole system in one place. Moving forward, so this is essentially the architecture that we saw. We have a user interface, user API at the very high level, which is essentially the intent, which allows the human to interact with this multi-agent collaborative system through the queries. This interface could be as sophisticated as a metaverse, as simple as just an intent and API. And then we see here the system of the multi-agent system. Through the automation layers, they can interact with the physical network, but also digital network with different replica that could, each of them, they could perform what-if analysis. If moving forward, so in nutshell, this orchestrator agent could, for instance, as we saw, talk to the SMO for the real-time observability and deployment actions. It could talk to the RIC and xApp and RAP for the deployment, and also FCAPS, for instance, fault configuration, accountability, performance, and security to perform anomaly detection, predictive maintenance, or even optimizing the network planning. And we see that one of the items here is this open ecosystem, this MX Hub, where new applications, new data models, and also new knowledge base could be shared among these agents, and they are also interacting through this twin environment. So in essence, the benefit of this approach is first is that this industry-aligned platform, which provides 3GPP and O-RAN compatible platform, allowing to integrate any xApp, RApp, and AI agent on the top, automated operations. So the automation layers that we saw is quite of essence to make sure that any actions could be deployed automatically. Accelerating R&D, this is essentially enabled through the development kits, the same way that the development of the mobile application has been accelerated through the Android SDK and iOS SDK. In the same vision, here we are accelerating the R&D by providing a brand new network software development kit to allow developers to, and also vendors and operators to innovate, and flexible integrations because it is standard compliant and has a lot of APIs. With this, I also finished a very brief picture of MXAI, what features it could bring to the community and how it could be useful to use it as a tool to do more research towards 6G. Now, I want to conclude and give you some takeaway messages. So the first conclusion I want to make is that the phase changes in telco ecosystem and economy driven by AI. So we saw that in the new perspective, the radio access network is the cost and the Gen AI is the revenue. That significantly, as you see here, showing the shift of this ecosystem and the economy of the telecommunication network, and all of them has been accelerated and has been started through the introduction of the AI. Second, most likely we are moving towards a variation of self-synthesized network. We want the network to be highly agile, highly dynamic, and highly adaptive. And we think that AI is the way to provide this capability to us. There are many questions unanswered in terms of energy efficiency, in terms of applicability of AI to the whole system. So a lot of research must be done. But the fact would be that we are looking into a self-optimized network that could learn and could adapt itself. And we put all of those under the umbrella of self-synthesized networks. Automation, intelligence, and open ecosystem and human-machine interface are the pillars here to enable such network. Without them, it is not possible to go towards a more dynamic network. And finally, MXAI, which was built on the top of 3GPP and O-RAN system, it has advanced multi-agent AI systems, which gives the possibility for agent-driven telecom network operations and optimization. So with this, I conclude my webinar today. I want to share with you also some of the showcase early prototype that we did together with some partners. So there are some videos available about the things I explained to you, together with some QR codes to scan to access some resources. And with that, I would like to thank you for your patience and your time here. And now I'm open for any questions.
Thanks a lot, Navid. Very nice, excellent presentation.
Yep.
And we are waiting for some questions from the audience. And please use the Q&A box for your questions. The good news is we had like almost 30 people, and some of them wrote that where they come from. One of them is from Liberia, from West Africa.
That's
Another
cool.
one is, yeah, it's very nice, really. So it's like worldwide. Another one is from Serbia, and then of course we have many other also friends from US and from Europe. So I recognize their names. So while we are waiting for questions, let me start my questions and then hope that will encourage some other participants to ask their questions. I like your MXAI agent solution. And one of the challenges is, especially for zero-touch network management, it requires seamless orchestration or across different vendors and domains. And so in other words, interoperability across multi-vendor systems. And as you mentioned, I'm just adding to your explanation that MXAI is an excellent solution for this problem because there is a lack of standardization machine learning model formats, telemetry data, and APIs, and they are slowing down the integration. So your solution could really help this problem, which you're trying to do, like, you know, you're promoting open standards and trying to solve this cross-domain machine learning model translation. So I believe that it has really a good future, in my opinion. So thanks for your presentation there. So I have some other questions, and I would like to get your opinion. These are more, you know, getting your vision view on this. So when you look at these real-time decision requirements for the future network management problems, as you know, that 6G will operate in through like very ultra-low latencies, you know, less than even 0.1 milliseconds. And then we need very fast decision makings. And as you know, the majority of the AI models need time to process, especially deep or complex models like GNNs, for example. What are your opinions or solution ideas for this problem? So I just want to get your opinion.
This is really a good question. So there are different dimensions I need to cover to answer your question. So
it's a broad question, Navid.
The very first one is that we believe that if the delegation is done properly, this smaller agent, so if the top level agent tries to clearly identify, and assuming that those specialized agent, task-oriented agents are deployed at the edge of the network, which are very close to the RAN, so they are not really deployed at the data center. So one dimension is deployment of those agents really close to the radio access network at the edge.
Like at the edge, right?
Yes. The other one, there are a bunch of techniques like quantization, you know, to kind of reduce having a large memory. There are like standard AI experts, there are a bunch of techniques to reduce the latency. But breaking down a big intent into a smaller and delegating in parallel to multiple agents which are collaborating and sharing, that is why I stressed a little bit on open ecosystem, would really help. I would say when we look at the physical layer, MAC layer, and RLC, we are really seeing, as you said, millisecond and sub-millisecond latency. As we are moving forward, like in ORAN, the near RT-RIG, that is the reason they call it near RT-RIG, because essentially, as you get further away from the base stations, maintaining that real time becomes challenging. So they have time scale of 1 to 10 milliseconds and 200 milliseconds. And as we go up to the management, the time scale increases. I would argue that those agents that are really down to the system, some of them might be in the future built in the RAN, right? I didn't talk about that. It could be that some of the agents are built in within the RAN, right? So that means that at some level, if this hierarchy and this collaboration works, we should be able to break down a big task into a smaller one, delegate, and execute directly at the cell site, right? Together with a bunch of AI techniques like quantization, you know, specific models and so forth.
And doing also more parallel processing, right? When
Yeah,
you
exactly. And that is GPU is good for anyway.
Exactly. And then, you know, through parallel processing, you can accelerate everything and have fast responses. And also maybe you can use some machine learning techniques which are event-driven, so that you can also reduce the processing time of these machine learning techniques. So thanks God, we have a question. Actually, I read through it and then I really like it. He has, you know, the person unfortunately tries to remain anonymous. Usually I don't accept them, but still. So I like the questions. So how can, you know, his question is, how can distributed apps can be integrated into the orchestration of ORAN applications to enable hyper-reliable and low latency communications, especially in scenarios involving the deployment and coordination of multiple apps? So that's the first part of his question. Shall I repeat or is it clear?
Can you repeat again? I have partially.
You can also see that in the Q&A box, Navid. How can distributed applications be integrated into the orchestration of ORAN applications to enable hyper-reliable and low latency communications, especially in scenarios involving the deployment and coordination of multiple apps?
Yeah, I have maybe two answers for it. When we are talking about we need to decouple the distributed app from the interface. When we are, for instance, implementing or designing distributed applications or parallel applications, majority of the consideration must go to the internal design of the app, right? Now, the fact that that app uses ORAN interface or 3GPP interface or for instance, AI interface is something completely complementary. So I would answer that at one level, it has to do with the design of the app itself, because when we implement it in a distributed way, it means that there is already inter-app communications that is not using the ORAN. Now, in terms of orchestrations of this distributed application, I would say one easy way to orchestrate those applications, I come back to your previous questions, is a time scale separation and also separation of the concern, right? Yeah. If like we could easily dispatch this type of applications based on the time they are requiring, the latency, the time scale, but also whether they are related to the control subsystem or management. I give you one example. In ORAN, there is this R1 interface that they define. It is there. So the R1 interface is a special interface that bridge towards either control subsystem or management or both. You could say a policy, I want that the example I gave you for energy efficiency, right? It could result in deploying an xApp to optimize the cell bandwidth, but at the same time turning off some of the base station, both control and management subsystem. So I would say that it depends on the logic of the app and how the app is going to be deployed, and then the time scale of the app itself.
And there is also the other sub question is also interesting. The question is about what role can LLMs play in managing this orchestration and mitigating potential conflicts between the configuration of different apps.
Correct. That is great. That is great. That is great. Yeah. This is a well-known problem. So back then in 4G SD-RAN platform and also more recently in ORAN, a lot of discussions and paper, they address the problem of the conflict mitigation or conflict resolution, right? Essentially the problem being two xApp that they are not knowing each other, they are sending a control command that are conflicting with each other, and someone needs to identify that, okay, because then you have the performance of the network going up and down, and a lot of fluctuations could happen. So when we look into the agent, that is why I talked about the open ecosystem. So we are seeing in a multi-agent system, there is a mediator. There is a mediator, and that mediator is sitting on the side of the operator, not on the side of the stakeholder and service provider. So that mediator agent could receive this intent, right, and then try to resolve the conflict or negotiate. That is why, again, I mentioned negotiation. If you have two stakeholders accessing this, like a slicing is a perfect example. A slicing is where you are sharing the network, right? It might be that two service providers want to change different parameters for their slice, but they are conflicting with each other because one wants to do energy efficiency, the other wants to do performance improvement. So this is the job of mediators, to negotiate and find a compromise between this intent, right? This is, let's say, we did some evaluation in terms of whether this negotiation and mediation should be distributed or centralized or decentralized, and it proves to be centralized being a little bit better in terms of performance. But regardless, there are a bunch of research could be done towards solving this conflict mitigation using agents. I don't have an answer for that because it's very new. It's very new.
Yes. You know, you mentioned about centralized mediator, but then it could be a bottleneck. So
yes,
sometimes
absolutely.
it's better to have multiple mediators,
exactly.
but you have to
Decentralized,
somehow
yes.
look
Yes.
at their coordination, cooperation, right? For
Yes,
that,
absolutely.
for that,
Absolutely.
you may use our game theory models from the cognitive networking, dynamic spectrum sharing. Remember?
Yes,
So we
yes,
can
I
do
read
it.
that paper. Yeah, absolutely. I think there are, that's why I said there are a lot of rooms to elaborate different architectures and how these agents, because whether we like it or not, we are moving towards multi-agent systems. There
Exactly.
is no way backward. So
Yeah.
that problems is surfacing already. You know, you already we
Yeah.
received the question. Yeah.
Yeah. And I wish this anonymous person would reveal himself or herself. I like his or her question, so I hope he will let us know. So I have one more question before Alessia can take over. This is again a general question. I want to get your opinion about security and adversarial AI threats. So as you know, everybody is like, of course, talk about AI and machine learning. And somebody asked another question. So AI itself can be a new attack vector, as you know. For example, poison
Yes.
models or adversarial inputs. So attackers could manipulate training data or interfere with inference in real time. So what do you think that how we can avoid those problems? It's also a research problem, but what do you think
No,
about?
this is also a very, very important question. We have a European project, and I was analyzing exactly this. I think agents are perfect to attack the system. With this level of knowledge and intelligence they can gather, they are the attack they could provide, the vulnerability they can find, order of magnitude higher than, let's say, just an algorithm and application. So I would say there are quite some architecture introduced, like a zero trust architecture that comes and essentially does the access control, strong authentication, and whitelisting, blacklisting, and everything.
Exactly.
I would say moving towards zero trust architecture, that is one level. The other is really to that mediator agent. We did some research on that. They could, so, each agent, this is, let's say, let me elaborate here. Agent essentially in a multi-stakeholder system, they could have different personality. You can have an agent that is agreeable. You can have an agent that is toxic, right? or an agent that could be malicious, right? So
Yes.
this is the job of the mediation, again, open ecosystem, to identify, and all of those could be, let's say, specified, like say, okay, what are the patterns that we exclude, right? You can also see it in our society, different countries, different persons, exclusion, inclusion. So I would say in certain way, we need to, the mediator agent needs to identify the personality of the agent, and then we saw that the mediator agent could convince any malicious or toxic agent to cooperate, right?
Yeah, it goes towards what you're saying is there are these AI-specific threat intelligence platforms.
Yes.
So it goes that direction, right? So that's what you're suggesting.
Yes.
And then also, like, there are many papers on federated learning, so maybe focusing more on the secure federated learning schemes. So I think this is also open question. Actually, I asked you just to get your opinion, but these are all open questions, as you know. And there is also a request from Yongchao Dang or Dang. He or she is from Aalto University in Finland. He wants to collaborate with you. And I suggest Yongchao to contact Navid directly and hope that you two can connect and then work together. So please feel free to contact him. And there are no other questions.
Sure.
I thank you, Navid. It was fantastic. We always enjoy these webinars, and you are also one of the super ones. And Alessia will take over now, and will ask you some career questions and personal questions, or life lessons, we call it. And just to let you know, and also the audience, Alessia doesn't share these questions beforehand, so that it's just spontaneous and just sharing your life lessons with the audience. So Alessia, please take over. Navid, thanks a lot again. I'll be back. So
yes, thank you very much for organizing this. Thank you.
Thank you very much, Ian. So thank you to our speaker for your excellent presentation. Now we move to the Wisdom Corner, live life lessons, which aims to offer a unique and special angle to this series of webinars, so adding a personal touch. So I would go with my first question. Looking back on your journey, what is the most valuable life lessons, or even a failure, that you have encountered and that shaped your path? And how can this lesson inspire or guide those attending this webinar?
In terms of professionally or personally?
Yeah, well, if you can share your experience, it can be either professional or personal.
I would relate it to the failure. I don't see failure as bad. I think failure is good. Fail quickly to succeed sooner, right? So, and there is also tradition. I noticed, for instance, big companies such as Google, they celebrate their failure. So there is nothing to be ashamed of the failure. There is no connotation, negative connotation to the failure. It's just a try, right?
Exactly.
Yes. So I would say there is no harm in trying. There is a saying that the big wins is a summation of a small wins, right? So always, even though things seems to be very big, but always starting little by little, small, and going forward. I would say another life lesson, really interacting with the great minds, sharing, students, any levels, right? There is no filter here. I mean, you could get a lot of nice ideas from a master's student or a bachelor student or from PhD. So having this flexibility to discuss with everyone, in a, let's say, in a equal way, is a chance. Yeah.
Excellent. Thank you so much. What key advice would you give to young professionals aspiring to build a career in academia or research? In your experience, what essential skills and qualities contribute most to succeed in these fields?
Like, you mean in what skills they
In
need to
academia
have?
and research? Yeah. What skills, what qualities do you think that they should have to succeed, to have a
I think
meaningful career?
one quality that I apply to myself is like, let me give like a starting.
Navid, while you are thinking, let me give you some time. So thinking,
I want to
FAIL means first attempt in learning.
Yeah.
N is not the end. In fact, N means effort never dies. If you get no as an answer, remember no, NO means next opportunity.
Good.
Thinking.
Thank you. You really encapsulate it nicely. I would say, but coming back to you, like, I would say, I say this to my students, doing a research is about time, energy, is an effort, right? And it's very important that we use them consciously and correctly, right? Today we talk about energy efficiency of the network, but we need also ourselves to be energy efficient. This is the only dimension we can control. So finding the right problem, right? And truly solving it, right? Because a starting task is easy. Everyone could start many projects. Finishing is the part that is very difficult, right? So finding the right problem, then truly going deep into the problem and solving that problem and finishing that problem at least to a certain stage, I would say is a good trait for the researchers to cultivate, and they accumulate little wins and they become more confident and more confident as they go forward. Having a lot of unfinished work doesn't give a good signal to the brain.
Yeah, fair enough. Very clear. What first inspired your passion for your field, and how did you turn this interest into an important career?
I mean, that is also a question that today I don't have a full answer, but I would say in many cases, I didn't make a choice, but the choice came to me.
Okay.
So it's a combination of like opportunity being open to you and you choosing the opportunity. Like all of us, I think we need to listen to the things that come to us and do not ignore them, right? That is what I did. Like, it doesn't mean I don't like other hobbies or other things to do. Of course I do. But at the same time, I was listening to what comes to me as well. And I followed my instinct as well towards that.
Yeah, of course. It's always a mixture of factors.
Exactly.
Absolutely. And then every path is unique for sure.
Yes, every path is unique.
Yeah.
And I think there is a feeling that happens where you want to put your energy. And I think listening to that gives right away the answer.
Yeah, very, very clear. Among your career achievements, is there one particular contribution, whether professional or personal, that has had a profound impact on you or on others? And what makes this accomplishment especially meaningful to you?
I would say So when I joined Eurecom as assistant professor in 2009, right? So I was working with two other professors, Professor Knopp and Professor Bonnet, and they have been starting the open source project that we know today, Open Air Interface. I don't know if you know this project or not, but this is essentially a project whose objective was to provide an open source platform for 4G network from A to Z, right? So this was a collective action in the faculty. So normally the faculty, if you go back in time in 2009, not today, professors, they don't like to do developments, they really want to do fundamental research and getting reputation and become really well known. And we were a couple of professors at Eurecom back then. We were like those Black professors that, they are doing something unorthodox, something like development, which is more engineering work, but we were looking into 3GPP. And it turns out that it was very much rewarding for us to learn the system and propose innovations and R&D that are aligned with the industry, right? Something that could come to life because today the expiry date of everything is very fast. So it's better to do something that is useful as opposed to something that nobody's gonna see, right? So at one level, the fact that we open source and share the code with community, suddenly, we had a community internationally, like a large number of people interested in the code, start using the code and, coming to our workshop. And that was quite rewarding. It was a teamwork. It wasn't my doing. It was a teamwork within the Eurecom. And then it led to the creation of the Open Air Interface Software Alliance membership, and then the 5G stack and all of those things. I would say that was, quite an achievement in allowing all the universities in the world to be fluent 4G and 5G. I can tell you this, we were back then the only one could talk fluently on specific 4G, what is this, what is that. Now I go to any meeting in any European project, everyone is fluent with everything. My assessment is that we paved the way through Open Air Interface, and later SRS RAN came, later other Amarisoft came, and this become more popular, right? It paved the way towards that. I think that was one achievement that I think was quite significant and impactful.
That's a perfect example. Thank you so much. Really excellent. Thank you for sharing with us your experience, your lessons. Ian, we are back.
Okay. Thank you again, Alessia. Also, thank you, Navid. Just before we leave, there's this young fellow from Liberia, Alfred Forle. He had a couple more questions, but I would like to encourage you to contact Professor Navid personally.
Yeah.
And you can ask him your questions, and I'm sure he will help you, Alfred. Thank you for your interest. And thanks to the entire audience for staying with us the last 1.5 hours. I thank you, Navid, for a very nice presentation and also Q&A, as well as your life lesson sessions. So I hope to meet you again.